This is lesson 5 of 20. As usual, pause the video, have a go in your own time. Welcome back. Well, the answer is Q equals 3. Q equals 3. There we go. I'm now going to look at how you could have done it. If this were me, I would do divide by 3 first. There's issues here. There's another way of doing it, which we're going to look at in a minute. Remember, you can use the bookmarks to fast forward in the video to the next question if you want. If I divide both sides by 3, I end up with 3 times q plus 1 plus 12 divided by 3. Right, with a divide by 3. Whoa, forgot the divide by 3. Now, they cancel, and 12 divided by 3 is 4. So I've now got q plus 1 equals 4. I can now minus 1 from both sides, q equals 3. This does not entirely follow the way that I teach. I generally encourage my students to expand brackets immediately. Why is that? Because, in general, it's safer. You don't have to do it, and sometimes it's slower, but in general, I find it's safer, and then you can kind of learn to improvise later once you're really getting really safe with it. So that's my thought there, which is, if it were me, I'd just divide by 3, but in reality, the solid, safe approach is go, there's brackets. Let me just get rid of the brackets first, just to clean it up, and then I'll carry on with the question. And I might have made it a bit more complicated, but it's kind of safer. Next question. Have a go in your own time. See you back here in a moment. Well, by inspection, x equals 0. Well, because something times something times something is 0, so it's got to be 0. You might put a cubed root in a circle to indicate that you're doing cube roots both sides, and then you go x equals 0. But it's all good. Next question. Okay, I'm just going to rewrite that because that looks slightly messy. There we go. Have a go in your own time. It's an unusual question for some people, maybe. I'm just going to go by inspection. Obviously, Q is 2. Obviously. Has to be. Because, why do I know? Because if I replace the Q with a 2, that's 5 squared, and 5 squared is 25. Boom, easy. Suppose you didn't spot that. We're going to learn a technique called make it look the same. Remember, you can skip forwards to the next question if you want to. Make it look the same is a very powerful technique. So I could look at this and I could say, I can't really pretend I haven't thought of this. I'm not really sure. Well, I've got 5 to the q here. There's not much I can do with it. I'm kind of stuck with it because there's a q. I can't do anything with it. I wonder if I could turn that into 5 to the something. Oh, that's 5 squared. So now I can say that by inspection, q equals 2. This version on the right would be my favoured approach in a very technical situation because I'd rather be clearer about exactly the process I was using. Have a go in your own time. See you back here in a minute. Okay. By the way, the answer is y equals 0. You could just say that by inspection. Frankly, I think that's okay. Well, because what's 10 minus 4? It's just 6. So something times 6 is 0. 0 times 6 is 0. Suppose you didn't spot that. You could go, well, let's simplify where I can. Let's divide by 6. Well, no, let's tidy it up first. That's 6y equals 0. Now let's divide by 6. Y equals 0. Oh, yeah. There we go. Next question. Have a go in your own time. See you back here in a moment. X equals 0. By inspection, again, we can just say by inspection again for this. You might divide both sides by 11. Alternatively, you might have said, well, something times something equals 0. We know the first something is 11, therefore the second something must be 0. That's a clear way of talking it through. I need to write a few things here. I'll let you know when I've finished, so don't pause the video yet. I have finished. Have a go in your own time. The answer is not possible. Haha. Tricky one, this one. Let's change to purple. I'm going to just act out trying to solve it. Well, it's debatable whether it's... You can say it's partly possible because we know that c equals 3, yeah? So at least we know that c equals 3. So you could say, you might have said partly possible. Anyway, let's take that and put it into that equation. That means that a plus b plus c equals, plus 3, because we know that c is 3 equals 10, minus 3 from both sides. A plus b equals 7. But wait a sec, we already know that a plus b equals 10. But it's just not possible. Those can't both be true at the same time. Therefore, it's not possible. I've said not possible. You could get like deep into kind of maths philosophy here and start talking about imaginary solutions, all that kind of stuff. Let's not do that. Let's just say it's not possible. That's fair. Yeah, that's fair enough. Next question. No prizes for guessing. There's another solve question, because I do like to start with solve questions in my lessons and then we move on to other stuff later. Have a go in your own time. See you back here in a minute. Not possible. Again, I've just asked 2 in a row that aren't possible. Oh look, an x and a y, that's 2 unknowns. And how many equations are there? There's only one equation. I'm just going to, boom, that's that. Just as a brief aside, okay, brief aside here, if there's one equation and 2 unknowns, is it always the case that it's not possible? No. Sometimes you can do it. We've done one of those before, haven't we? Because we've had things like a times b equals 0, and we say, well, a equals 0 and or b equals 0. And there's other exceptions, but ignoring that, oh, there's 2 unknowns, there's one equation, we can't do it because we need more information. Next question. Got some calculators. I'll let you know when I've finished writing them all out so you know when you can pause. Oh, look, it's another pattern. I wonder what this pattern says. Maybe you could think about what do you think is useful for you in this pattern that helps. That's all of them. See you back here in a moment. Let me just write the answers. For me, this is really useful because I've always found questions like, for me, questions like this are always difficult. I always find myself like triple thinking it, going, wait, hang on, which number's bigger? But that one isn't minus. And then I'm often doing things like thinking, wait, there's nothing in the front. Does that mean anything special? No, it doesn't mean anything special. It just means you. Anyway, point is, whatever. Remember to use these patterns to help you kind of understand better some of the more intuitively difficult bits of maths. Let's do another calculate question. 3 of them this time. So once I've written my 3 out, you can pause the video, have a go in your own time. Do you remember the 2 squared thing? So please take your time with this, don't rush. I meant 2 cubed. Do you remember the 2 cubed thing? I just said it wrong. Okay, welcome back. Right, so that's -1 times -1 times -1. -1 times -1 is +1. So the answer is -1. This is a half times a half times a half, which is 1/8. I'll come back to that again in a minute in case you need some extra help. This is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Skip forward if you want to. Let me just look at this one again. You've got a half times a half. What if it was a half times a half? Well, then you just multiply the top and bottom of the fraction. So that's 1, and 2 times 2 is 4. And then this then needs multiplying by half again. So 1 times 1 is 1, 4 times 2 is 8, and that's your final answer. We can't do everything in this course. Go and check out, I've got a free maths book with like over 100 more maths videos on another playlist on YouTube. You might go and look for some extra info on fractions there. And there's loads of other teachers that have put free stuff on YouTube and lots of other places. So if you want to do some more practice of fractions, go for it, see what you can find. Same to both sides again, because I do like this. I think this is very important. Now, I've got another bonus lesson on this as well. And guess what? They're getting progressively weirder. Have a go in your own time. See you back here in a minute. Okay, here we go. I'm just going to write it out fully. I've just written that wrong. Immediately done that wrong. Sorry. Here we go. Now, they cancel because if you have y and then minus y, that's it. But you can't cancel anything else. That's it. We're going to go on to the next question, but in case, I just want to address now something in case you're doing it. So skip to the next question if you need to. Let's look at a mistake. This is a very, very, very common mistake that someone writes this. So you can rearrange it. Put that y minus y there. And then you can say, oh look, well I can cancel these y's. This is wrong, by the way. This is very, very wrong. And then you might have simplified that to 8x. This is wrong. The best way I know of to prove that this is wrong is, what if you had 10 times 2 minus 2? That is 20 minus 2, which is 18. Now let's do it wrong. Oh, that's 10 times 2 minus 2. Well, that just cancels. So it's just 10. No, it's not. It just isn't. You can't do it. So here's the thing. Why can you cancel it on this side? It's because you clearly have two almost identical objects with nothing else interfering them, which cancel each other because they're doing opposite things. You just need to practice it and get more and more used to exactly that clarity. Yeah, maybe talk about that another time as well. Next question. If I can find it, I'm currently struggling to find it. Here we go. I'll let you know when I've finished writing it out. That's it. Have a go in your own time. See you back here in a minute. And the answers are 1, 3, and 3/5. Move on if you're happy. Just a brief thought. Oh, look, that's 4/4, which obviously just adds up to 1 because you can split it up to 4. That's 1, that's 1, that's 1, so that's 3. This one you can say out loud, 2/5 plus 2/5 plus 1/5 equals 3/5. 2 elephants plus 1 elephant gives you 3 elephants. Next question is a plot. I'm sure you can guess what the question will be after we've plotted everything. Okay. Have a go in your own time. I'm just going to plot these axes quickly. Right. Let's plot the first point, 0, 0. Oh, well, that's obviously there because it hasn't gone anywhere. Hasn't gone anywhere along the x-axis, hasn't gone anywhere along the y-axis. What about 3, comma 3. Well, x is 3, and y is 3, so it ends up here. Minus 2, that ends up here. Minus 5, that ends up over here. What's the line here? What's the rule? What's always true? What's always true is that the x value is the same as the y value. How do we write that in maths language? We say x equals y. Let's do the next question. Whoops, I just did something weird. Okay. This is a calculate question. And that is a 4, by the way. Pause the video, that was all of them. I'll give the answers in a sec. Okay, the first one is 1. The second one is 90. The third one is 4. Now let's look at those in more detail in case you want to have a look at them in more detail, otherwise you can obviously skip. This one here, that's 10 minus 3 times 3, which is 10 minus 9, which is 1. This one here, oh look at the brackets thing again. So that's 10 times minus 3 times minus 3. Because the squared is acting on the brackets. Minus 3 times minus 3 is 9, so that's 10 times 9, which is 90. This one here, 10 minus 4 is 6, which times by 1 makes 6. Look at that. I am only human. Apologies, I just got that wrong. Next question. And that's it. Have a go in your own time. See you back here in a moment. I'll just give you the answers straight away, see if I can actually get them right this time. I can't, do you know what? I can't do this one. I'll just do this one live. That is 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 makes 8, times 2 makes 16, and it's 32. Right, so the answer to that one is 32. I'll just double check it. 2, 4, 8, 16, 32. Yes. That one is simply 3 times 3, which is 9. This one you might be thinking, why is there a 2 there? Well, skip to the next question if you don't want to hear this. Have you ever seen this before? That means cube root. What's the cube root of 8? The cube root of 8 is 2 because I need to make some more space here. 2 times 2 times 2 equals 8. The cube root means what times by itself 3 times makes 8. So if I write the square root of 9 is 3, I can say it's because 3 times 3 equals 9. Do we normally just write the square root of 9? We do. Is this a pet hate of mine in mathematics? It is. I don't know why mathematicians are lazy, but they are. Anyway, next question. This is the last question. And this question also has a bonus lesson about it later, in case you want to watch it, but you don't have to. I'll tell you when I've written them all out. There's a few. Oh, that was supposed to be a plus sign. Have a go in your own time. See you back here in a minute. First one, I can see that they've got a 3 in common. I have to have a plus sign in the middle, and then x goes on the left, right goes on, y goes on the right. This one, they've both got an x in common, because remember this here is x times x. I need a y there, because x times y is xy, and x times x makes x squared. This one, I'm going to have 3 things in the bracket. I could put a 7 outside, that'd be an x and a y and a 2z. This one I can put an 11 outside. Some people might have found this tricky. What goes on the right here? The answer is 1, because 11 times 1 makes 1. This final one is not possible. Why is it not possible? Because they share nothing in common. At least I'm sure that some of you have done this. To which I doff my cap and say, well done, good effort, you've taken a 1 out, which is kind of technically factorizing. You know, congratulations, but not really what is meant by factorizing. So there we go. See you in the next video. Remember, just do one video per like half week, one video a week, one video a day. Don't do more than one video a day. But you can obviously do extra bonus videos. Anyway, that's kind of how these things are designed. Okay, anyway, see you next video.